So we studied all the other terms. Now 11.5, we're going to study secant and tangent, and those refer to lines. Remember, secant lines are lines that go through the circle twice, so they hit twice. So here it hits once, here it hits twice. That is a secant. Versus tangent is only going to touch it one time. It's just going to skim the outside, and there's only one point of intersection. So those are the differences between secant and tangent lines. So a tangent segment is a line segment formed by connecting an outside point of the circle to the point of tangency. So a tangent segment is going to be a point right here that is tangent to the circle. It means it's on the circle. And there's a point out here, and then you're drawing that line to them. Notice you've got two tangent lines up here. So the tangent segment theorem states if two tangent segments are drawn from the same point on the exterior of the circle, so point exterior of the circle would be A, then the two tangent segments are congruent. So the tangent segment would be AT, that line segment would be congruent to AN. That's what this theorem is stating. Remember, on Friday you're going to have a test. You need to know all these different theorems that state why you know that this is congruent to this. And on the test, I might say 3x plus 15 equals 45. And then you have to solve for x. And then you're supposed to know, oh, wait, the tangent segment theorem says that this is congruent to this. That's not going to be on the test. You're going to have to know that. And then you're going to set 3x plus 15 equals 45. You're going to use your basic algebra skills, minus 15, 3x equals 30, divide by 3, x equals 10, and that could be your answer right there. And if I check that and I plug it in, 3 times 10 is 30, plus 15 is the 45, which means this is 45, and that's 45. And that's what the theorem is stating. So that's the type of questions they can ask. You're going to do some of those in skills practice. All right. Secant is a line segment that's formed by two secant intersecting outside of the circle. A secant segment begins at the point at which the two secants intersect, continues through the circle to the end. So if I was talking about the secant lines up here, there's a bunch of line segments. Hopefully you see that AP is a line segment. That is not the secant segment that we're talking about. But you see hopefully D or PD, that line segment from here to here starts at the point of intersection and continues all the way to the other side of that. That would be where it exits the circle. All right. So the other one, which we did was AP, that would be referred to as the external segment, secant segment, which is the portion out here. All right, so that's these are just terms, these are definitions. Please make sure you know them. We're going to come up with a theorem here right now. So the secant segment theorem states that two secant intersect in the exterior of the circle, then the product of the lengths of the secant segments and its external segment are equal to the product of the lengths of the secant and its external. All it's saying is if you take CS, which is this whole segment right here, so CS, and you multiply it by CE. So this whole part multiplied by this little part. And that is going to equal this whole part times this whole part. Those are the pieces that it's talking about. I'll erase that so you can see that a little clearer. Okay. So CS times CE, those lengths, is going to be equal to CN times CA. And I believe this is our last thing to go over. The secant tangent theorem states if a tangent and a secant, so now we got tangent and a secant intersecting, then the product of the secant segment and its external is equal to the square length of the segment. So here's what it's saying. If you have this length right here, which is AT, and you square it, it's equal to the length of this whole thing times this. And that's all the theorems. Again, how you use them is they're going to give you lengths. You're going to solve for unknowns. You've got an equation down here, and once you have an equation, you can put an x anywhere in there, and you can solve for that. That's it for today. I tried to make it a quick lesson. Make sure you know your theorems. There are a ton of them. I've told you, vocab, 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 right? Avin, give you a little shout out, saying that that's my 3 favorite words. So please, study your vocab, know these theorems, then the rest of it is just, you're allowed to use it now. You're going to set things equal, and the rest will be algebra where you're just solving for x's or anything like that. I will not see you for the next couple days. Enjoy the substitute. Hopefully they're nicer than me. I will see you when I return. Go Florida State.